Hey, how's it going? So I guess we have a competition, so let's do the competition. Contest. 16 seconds. I'm early. All right. This will be fun. Got my tea. Well, I'm assuming it'll be fun. I get frustrated if I can't do the problems. Come on, come on, come on, come on, come on. Join now. 18,409 people. I wasn't expecting it to load a new tab. Best time to buy and sell stock using strategy. You're given two integer arrays, prices and strategy, where prices of... Oh, no, is this one where we don't have any easy... Oh, wait. We don't have any easy... okay. Prices I is the price of given stock on the ith day. Strategy I represents a trading action on the ith day, where -1 indicates buying 1 unit of stock, 0 indicates holding the stock, 1 indicates selling a unit of stock. You're given an even integer k and may perform at most one modification to strategy. Modification consists of selecting exactly k consecutive elements in strategy. Set the first k divided by 2 elements to 0. So we get a k. Oh, we do get a k. Okay. Set the last k divided by 2 elements to 1. Return the maximum possible profit you can achieve. So prices, strategy. So there's just one stock, right? A given stock, yeah. So this is going to be a baseline, and then so basically we have to roll this across this and see. Selecting exactly k consecutive elements, the first to hold and the last to sell. Interesting. That is kind of interesting. Okay. I think we're going to do this as 2 passes. We're first going to do a basic pass. All right. You're given an integer and may perform at most 1 modification. Okay, but then whatever we do after that is going to what am I trying to say? It's going to like compound. So, you know what? Maybe we do need a 2-dimensional array. So our options are let's see. Buy, hold, sell. There are no constraints on budget or stock ownership, so all buy and sell operations are feasible regardless of past actions. So I assume we can short sell. That makes sense. Okay. We'll say best what? What are we going to start? We're going to say cost. And it'll be a 2-dimensional array. And it will be 0 for I in range length. Prices. The length of prices is the same as the length of strategies, right? Yes. Yeah. Then for j in range 2. So the first will be if we have done it, and the second will be if we have not done it, right? And actually, the cost should be very high. So 10 to the 5th times 10 to the 5th, just whatever, just 10 to the 5th times 10 to the 5th is what? Is it 10 to the 10th? All right, we'll just make sure that it's bigger. All right, so very, very expensive. Oh. The cost needs to be 0 when we start, doesn't it? I was not thinking about that. Okay. So this will be length prices plus 1. And then cost of 0, 0 equals 0. That is our starting point, right? All right. Okay, so we will say for I in range length prices, and then, okay, so we're going to say current cost not used equals cost I 0, and then current cost of used. Okay, are we just buying one stock? Indicates holding the stock, buying 1 unit, selling 1 unit. Okay, so you can sell 1, sell 1, sell 1, sell. All right. Okay, this might actually be easier than I thought. Okay. So now we need to calculate current cost used. Yeah. To do can use. Yeah, that will magically change things. But we have not done that yet. So just the basic case will be new not used equals new used. So this is our base case. Cost, well, it's just this. Okay. So if we sell, the prices are, okay, they're integers. So let's see. This really confuses me here. Buying 1, okay. Minus strategy of I times prices of I, right? So if we're buying 1, then that's positive multiplied by, yeah, so that will make our cost go up. And if we're selling, then that will make our cost go down. And used is the exact same thing. We're just proceeding with the one that got used. Okay, now let's figure out the used one. New used alt equals 10 to the 11th. And that's so high that, like, if it gets used when it's not supposed to, I don't care. All right, now if I is less than k, is that no? If it's greater than k, if it's greater than or equal to k. So let's try to see if k is equal to 2. Then the first time we would be able to use it is at 1. So it would be if I plus 1 is greater than or equal to k. And then it would be hold, sell. This is going to be n squared unless I keep a running total of all of the cell costs. So 10 to the 5th, yeah, that can't be n squared. That's not going to work. So we have to, we'll say sell price equals 0, and then sell price run equals, well, 0, right? Okay, new used alt, and then new used equals min, because we want the smallest cost of new used alt, and new used. Okay, we need to increment the k right here. We will say sell price plus, minus equals prices of I, and then sell price run plus equals 1. Now, while sale price run is, let's not do this. If sell price run is greater than k divided by 2, then that's a problem. We need to fix it. Prices minus the oldest one, so k divided by 2, right? So if k were 2, then that would be 1. We're at 1, so we need to get rid of 0, and this would be 1 minus 2 divided by 2, which is 1, which is what we want. Okay, and in that case, then the new used alt Now I'm worried that I was doing it wrong. Yeah. Previous equals 0. If what? Well, we know that this is valid. So if sell price run plus 1 is greater than k divided by 2. Crap. If I is greater than, just having trouble telling where the variable is coming from. If I is greater than k, then we can subtract k from it, right? So the new used alt is going to be the sale price plus cost of never used I minus k, right? Sell price plus cost of 0, I minus k. But won't this always be true? No, it will not be true for the one before. All right. New used alt. used alt. Okay. And then we put the new used here. And then, once we have both of them, then we write the value. So cost vi plus 1 equals new not used, which is basically a pre-calculated value. There's no choice there. And then this one is where the choice can come from, new used alt. But, wait. Not used. Used. Did I do that anywhere else? No, because the only other place that I grabbed it was right here. Yes, I did screw it up. 0 I 1 I. I'm almost convinced that there's an off by 1 in here somewhere. I was just scratching my head too much. So the ending price, right, is going to be, yeah, so -1 times 4. Yeah, so the cost. Are we going to want the negative? The maximum possible profit is 9, which is the inverse of the cost. So we want return negative min cost last one. All right. What do you mean? What do you mean not available? 2 8. Output is 8. Output is supposed to be 10. So far off to a bad start. So let's see here. The original is You know what? This is absolutely ridiculous. Let's redo this. Okay. Def R. Yeah, we're gonna have a position. Never used. This will be LRU cache none. I mean, it's just a bunch of additions or subtractions, right? I mean, that's all that it is. Okay. So, if I equals -1, then return 0. You know what we'll do if it's less than 0. Let's have this be already used. I prefer that. Because it's like, where have we already used it? And we don't know the answer to that. So it's going to start at the end. Ah, that doesn't make sense, because then I'd have to specify, and it would have to know which one was used. That doesn't make sense. It needs to start from 0. Okay, it can start from 0 then. Okay. It's starting from 0 then. So we want the best. All right, this is easy. If I equals, if it's greater than or equal to length of prices, then return 0. Nothing. Yeah. Now, the basic is just going to be prices of I times strategy of I times -1, right? Because we want to return the profit. So the maximum possible profit, and if we are buying, we don't even need to multiply it by -1. That was just because I was doing cost before. Okay. So basic. Now, if I plus k is lesser than length of prices, let's make sure that that makes sense. Then we do something. I plus k. So if we're at 0 and k is 2, then we can jump to the end, right? Yes, we can. I think we might need to accumulate the prices, but that's okay because that can be figured out. I plus k is less than or equal to length of prices. Then basic 2 equals -10 to the 11th, right? Okay. If I plus k is less than or equal to prices, then we need to calculate what it's going to be. So it will be, and not already used. Then basic 2 is r of I plus k, true, plus, so, k elements to hold, and then let's say accumulate prices equals list of accumulate of prices, and then I find it useful to have a 0 at the beginning, and then we will say the profit from selling is going to be sum, no, not the sum, a underscore p of I plus 1 minus a underscore p of minus k divided by 2. Is that correct? Is that correct? So let's do the example of k is 2. So k divided by 2 is 1, right? Now we are going to be at 0, and we want to add 1. That's the only thing that we want to add, is just 1. So it should be 1 first off, oh, this is right. This is right. We're going the wrong way. That's why it's wrong. That's why I'm confused. Okay, so a underscore p of I plus 1. So let's just take this example right here, right? The accumulate of that is going to be 0, 4, 6, 14. Okay, and we're going to be at I equals 0. And so what we want is we want 2. Which should be 6 minus 4, which it is. So we need I plus 1 plus k divided by 2 no. I plus k, 0, 1, 2, minus I plus k divided by 2, 0, 1. Huh. Okay. Now return max of basic and basic 2. Return R0 false. Please work. Let's see, 10 and 5. Oh, something's wrong. Print I already used basic and basic 2. So something is going wrong here. Let's see, output 5. It's just instant. Well, that doesn't make any sense. It should be iterating through the array at the very least. Oh, for hell's sake. Plus R of I plus 1 false. No. Already used. Well, the debugging statement worked, I guess. So 9 and 10. Please work. All right, accepted. Oh, phew. Well, that went poorly. So, XOR after range multiplication queries. 1. You're given an integer array nums of length n and a two-dimensional integer array queries of size q, where queries of I equals LIRI K1 V1. For each query, you must apply the following operations in order. Set index L of I, while IDX is less than or equal to RI, update nums index equals return the bitwise XOR of all elements in nums. So update nums range multiplication queries. I'm trying to figure out what the hell this is even doing. So nums and queries. And the query is LIRIKIVI. So it's being passed a bunch of parameters. Okay, 10 to the third. The bitwise XOR of all of the elements in nums. Can this just be brute forced? Am I missing something here? 10 to the third, 10 to the third. That's like at most 1 million, right? Okay. Update index times VI modulo 10 to the 9th plus 7. What? This is a weird question. Okay, so okay, a bitwise XOR of all of the elements in nums after processing all queries. So left to right, multiply it by V. All right, okay. I think I'm starting to get it. Maybe there's a trick, but I don't really think it matters. So base XOR. Can we accumulate the XOR? I think so. I can't remember the notation. I don't want to screw it up. Let's say accumulate XOR just equals 0 times length nums plus 1, right? And then we will say accumulate XOR equals, or we'll say for I in range length nums ACC XOR of I plus 1 equals nums of I XOR. Right? I feel like that's kind of a weird way to do it. Yeah, that would allow us to extract a... But that's stupid, though. That's stupid because we're going to have to iterate anyway. Like, what's even the point? We're going to say basic XOR equals 0 for I in nums B XOR equals I, like that. And then for each element in the query, we'll just say, I don't know, for I, well, here, let's do this. Return value equals this, and then we will say for query array in queries. Do we even have to do that? I don't think we have to do that. I think we can just go like that directly because Python is awesome. Yeah. And then just current XOR equals B XOR. And then we're just going to replace it, right? So we're going to say for I in range li ri plus 1, right? Then just we're going to undo the XOR operation. Undo the XOR operation of the original. And then we're going to apply the new XOR, which is times, and how big can VI be? Not even that big. Oh, I almost missed the K. nums I times vi, the whole thing, modulo m. And then just when we're done, we just ret.append cx, right? Just seemed really confusing how it was written, but it wasn't actually that hard of a question. Output 31, what the hell? XOR all of the elements. Oh no. Oh no. I misunderstood. All right. It says queries. I was expecting a sequence of results. So apparently I'm supposed to destructively modify this. Okay, so nums index equals num index. Just like that. Times vi. Alright. Okay, so name ret is not defined. Indeed it is not. Okay, 4 and 31. Sweet. Alright. Okay, minimum sums after divisible sum deletions. You're given an integer array nums and an integer k. You may repeatedly choose any contiguous subarray of nums whose sum is divisible by k and delete it. After each deletion, the remaining elements close the gap. Return the minimum possible sum of nums after performing any number of operations. To the 5th, 10 to the 6th. K goes 10 to the 5th. Well, because you have to remove contiguous sums, would there ever be a reason that you wouldn't want to remove a contiguous sum? It would be because it was needed elsewhere, right? Okay. Any contiguous sum is divisible by k. The thing that you want to notice is that if it's divisible by k once, it's going to be divisible by k multiple times. So you wouldn't want to hold on to something that was 1 times k, hoping that it was going to be 2 times k later. In other words, if you have hit something that's divisible by k, then you would want to remove it. Right? Right? Okay, the first thing we should do is nums equals I mod k for I in nums, right? That's just an absolute given. Get it down, manageable. So you might leave something and it could be divisible later, right? Is that going to be like a stack? Stack of every single... Interesting. I don't know if I'm going to be able to figure out how to do this. Nums equals I of k. What if we don't need to be smart about it? What if... No, that's going to be n squared. That's not going to work. Okay, what if we start at the end and then if there isn't something divisible, then we know that we have to count that. And if there is something divisible, then we can skip that part. I mean, if I have to branch every time something could or could not be divisible, then it's guaranteed to time out. So I'm going to take a gamble and say that hopefully that's not necessary, because that's what I got. That's all that I got right now. So let's say accumulate nums, right? Nums accumulate equals accumulate nums. Yeah, you would want the first instance of something. List of accumulate of nums. This just keeps getting weirder and weirder. Yeah, but every time you take a chunk out, then the range of things that you can look at, it's going to be like a two-pointer thing. Right? Yeah. NA. So if you're at a 0, then you want a 0. If you're at an n-1, then you want a 1. Right? Yeah, you get rid of a first index, and then what? Like, how do we keep track of that? Well, we got to assume that we're starting from the end, so... we can start from the beginning, that doesn't matter. For I in range length nums like that. And then we would want the last index. So last index equals like that, and then we would say, not nums, NA, at last index, NA of I equals I. But once we've used the last index, well, no, we would never come to an earlier one. That doesn't make any sense, and there can't be a last one after that. And then you skip that range because you've removed it, right? Okay, I think I understand. We're going to say I equals 0 like this, and then while I is less than length NA. All right, so current number equals NA of I. Now, needed number is going to be K minus current number if Cn doesn't equal 0, then it's that. Otherwise, needed is 0. Otherwise needed is 0. Okay, then what's my time remaining? 43 minutes? Ah, we're good. We're good. We're good. Okay. Now, if needed in last index and last index of needed is greater than, not greater than or equal to, just greater than I, then we can skip. We can skip. I equals last index of needed plus 1. So we have removed that. Otherwise, we can't skip. Which means we are forced to eat the number. Tot plus equals the remaining sum is 5. We can't use the modulo number. We have to use the original number. Nums of I. Right? Okay, return tot. List index out of range. Oh. All right. 1, 0. 5. Well, 5 is correct, but 0 is not correct. K is 2. How could it? Okay, something screwed up, because that would be 1, 2, 3, but then it would be 1, 0, 1. Oh, God. All right, I'm back with water. I don't know that I have any ideas, but okay. I mean, I feel like I could write an n-squared algorithm. Maybe that'll give me some insight into how to do the rest of the problem. So, put I in We want to see if there's I think we need the accumulate. I do. So accumulate, just ACC equals list of accumulate of nums, right? And so we want everything except this. So it's going to be, nums of I plus ACC of -1 minus ACC of I plus 1, I guess. Right, because we're going to have 1, 2, 3, 4, 5. We shouldn't need both of these. This is why I like the 0 at the beginning. We don't need a special case. So the very last one minus I plus 1. So the accumulate is going to be 0, 1, 3, 6, 10, whatever. I think I went too far. So yeah, so like that. So it'd be, if we're on the very first one, it would be 10 would be the entire thing, right? Yeah. Okay. Now, if the end is divisible by k, then first off, if k equals 1, then return 0. So now that takes it to the very end. But that isn't necessarily I equals 0. Less than length nums. Okay. So we want to see if there's any sequence that we can remove. This would just be the last position that we could possibly remove. Then we would have tried. If we've tried and it didn't work, then then there's nothing that we can do. So if nums of I mod k in tried, then there's nothing that we can do. So we just add the total. This is not going to work. Total plus equals nums of I. I plus equals 1 and continue. Otherwise, tried dot add nums I plus k. So that didn't work, then we're going to start at the end. For j in range. Yeah, if nums of I mod k equals 0, then I plus equals 1, and continue. There's no reason to waste any time on that. Okay. So, try dot add. So, for j in range, it would have to be I plus 1 through length of nums. And then we want it to go backwards like this. So value equals ACC of j minus ACC of I. Yeah. Found j equals -1. So if val mod k equals 0, then we found it, right? Then we say found j equals j and break. Otherwise, we're going to loop, which is probably going to make us time out, but whatever. I'm just trying to see if I can get anything to pass. Now here, if we found a j, then we don't add this I and we don't add any of them. We say I, well, just equals, well, if found j is greater than or equal to 1, whatever, it's greater than -1, then I equals found j and continue. Otherwise, top plus equals nums I plus equals 1, then return tot. Invalid syntax. Oh, right. All right, 1, hey, that's right. 5, that's right. But is it going to time out? I'm hoping that for a reason I don't understand, this is going to save me. Well, not this, but this in combination with this. But maybe not. So we'll see. Okay. I wasn't expecting it to give a wrong answer. That kind of surprises me. Yeah, I mean, obviously it should have removed the entire thing. So that is just straight up bizarre. Print I try tot so it tried one. Oh. We don't want tried, we want failed, right? Interesting. Okay. So if it didn't find it, then we put it in here. Let's get rid of the print. Expected 0. Oh, no, 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 no. Come on. I fixed you. Zeros, yeah, God. Something odd is going on here. Print found match I found J. Unknown network error. Don't do that. 9179. So it's saying that it failed to find a 1. I find that very odd, actually. Found match 8,8. Yes. Failed to find match. Unless my entire strategy is flawed. Going as far as possible is a mistake? No. Maybe you really do have to strategically start somewhere in the middle of the sequence in order to clear up other things. A stack. All right. Well, I don't think I'm going to be able to figure that out. Let's look at the last one. XOR after range multiplication queries 2. You're given an integer array nums of length n and a 2D integer array queries of size q, where queries of I equals L of I, R of I, K of I, V of I. For each query, you must apply the following operations in order. So far, it looks identical. Set index, update, return the bitwise XOR of all elements in nums. After processing all query, well, I'm missing something here. This is like literally the same problem. This is literally the same problem. What am I missing? Oh, it's just the length has changed. Ten to the 5th. Run. 4. 31. Uh-oh. Getting nervous that's going to time out. So the question is, And it's the $1,000,000 question. Can we speed this up in 17 minutes? All right. So let's see. Multiply it, modulo. Yeah, but it has to be iterative, though. Because the operation would change the previous value, right? We just say what all operations were applied. It's almost like every single one of these needs to have its own multiplier, right? And then we pre-calculate the combined multipliers. Okay. I might be able to do that. Okay, so let's see here. So V of I is always positive, right? So we could signify the end with a negative. So let's say operations equals an array like this, right? Now, instead of actually iterating through these, we will say li. What is li? Li is the start. So operations dot append li of vi is what we multiply by, right? Yes, I think so. All right, and then we remove it at ri. So we'll just call that, I don't know, negative vi. Yeah, that sounds good. Okay. Li, ri. Okay. Oh, no. Oh, no. It's not going to work with the ki. It's not going to work with the ki. This is not going to work. I mean, maybe. I wonder if I could specially treat the different KIs. No, it would need to. Well, think about it. If K of I is high enough, yeah, we could have like 2, 3. Well, I mean, it would need to go to like 1,000. I mean, that is ridiculous. We have 12 minutes. It's ridiculous. But this is not... This is stupid. I need an efficient way to know what the multiplier is, right? Okay. Multipliers, I guess. But we're not going to know where to remove it, though. That's not true. That's not true. If we can calculate the first time that it wouldn't have fired, then maybe there's a way. Okay, so multipliers, we're going to use these down below. It doesn't matter. Even if this would work, you can't do it in 10 minutes. Okay, Li vi of k, Ri vi of k. We need to know if it's going to hit Ri. How would it hit? If Ri minus vi mod k equals 0, then it will hit. But this was supposed to be the place where we removed it, right? Ri plus 1. We need to remove it the first time that it isn't going to fire. Not the first time it is going to fire, the first time it shouldn't fire. And it has to be the time that it's at 0. So, let's see. So Ri plus 1, let's call this adjusted Ri equals Ri plus 1, right? Adjusted Ri. Okay, so what do we have to... Let's say we want to get to a multiple of 10. So we're going to say 8 mod 10 is 8. We need 2. So it's going to be 10 minus 8 mod 10 is 2, right? Yeah. Equals Ri plus 1. That's where we want to remove it. ARI plus equals K minus ARI mod. Is that right? No, because it's going to be stepping. It's going to be stepping. So the distance equals ARI minus LI, right? That's the distance. So distance plus equal ARI plus equals K minus K minus distance mod K, the whole thing mod K. Right? Then assert that distance ARI minus LI mod K equals 0, which it should now, right? Show me that it does in these. K is not defined. Did you mean KI? I did. I did. K is not defined. Maybe I just should have called it K. Oh, go to hell. Oh, come on. How many times? Alright. I'm going to lose because of that. No, I'm not. Okay. Ri minus Vi. Okay. So now we are going to say for I in range length nums. You know, we don't even need to do that. We just... No, it does. Range length nums. Operations dot sort. Okay. This is going to run out of memory the way I'm going to implement it. Okay. While operations and operations of 0 equals I, right? And we're going to say liviki equals operations dot pop 0. We will remove this. And then, yeah. So, if ki not in multipliers, then multipliers of ki equals 1 times ki, right? Yes. Now, if vi is less than 0, then multipliers ki of 0 divided by equals negative vi. Otherwise, it's multiplied by it, right? Yes. Yes, it is. Okay, now we have to say number equals 0. And we're going to say j. Well, we need to figure out all of the multipliers, so we will say current multiplier equals 1, and then for j, whatever, k is fine, I guess, in multipliers dot keys, not going to make it, yeah, and then we need to cycle through all of them. Yeah, ARR equals multipliers of k, and then CM, well, XX equals ARR dot pop 0, ARR dot append XX, CM times equals XX, CM, yes, current multiplier. How did the indent get screwed up? I don't have time for your shit right now. Okay. Current multiplier. Then what is it? Yeah. Current number mod equals CM times nums I mod 10 to the 9th plus 7. Right. Invalid syntax. Invalid syntax. Why? Why is it invalid syntax? Multipliers. No, that's not it. Because multipliers. Oh. I guess that's valid. Dude, what if it worked? Cannot access local variable k. Do not have time. Not supported between tuple and list. These were supposed to be tuples. That's how they're going to sort. That does not look right. I think we're thwarted. Well, that's too bad. All right, I guess let's look at the leaderboard. Leaderboard, the what? All right, 8 points. Don't feel too great about that. So. Hey, look, it's the people who can actually code. Is there a way to jump? I mean, this is kind of a pain. Oh crap, I went further than I meant to. Okay, so 3,000 or something. Tie for like 32nd, 100th place. Some of these will be rejected because people cheated, but I would have liked to have gotten that hard. Oh well. Okay, see ya.